Chapter 7 Internal Forces. Okay, everyone. Today we will talk about something very important in making sure bridges, buildings, and machines don't break. It's called internal forces. Imagine you are holding a big stick and your friend starts pushing on it. You will feel the stick pushing back against your hands, right? That invisible push inside the stick is called internal force. Even though we cannot see it, it is there inside every beam, column, or machine part, making sure it doesn't snap or bend too much. First, when something like a beam is being pushed or pulled, we like to cut it in half, like slicing a sandwich, to see what's happening inside. This cutting is just pretend. We call it making a section. By doing this, we can draw arrows on the cut side to show how the inside of the beam fights back against the push or pull. These arrows are what we call internal loadings. There are three main types of these internal forces. The first is called normal force, which is like pulling or pushing the stick straight along its length. If it pulls apart, it's called tension. If it pushes in, it's called compression. The second is called shear force, which is like trying to cut a carrot with a knife. It pushes the two parts in opposite directions sideways. The third is called bending moment, which is like you trying to bend a ruler. It tries to make the stick bend and twist. Sometimes in machines or 3D structures, we also get a twisting force called torsion. Engineers use simple math rules, called equations of equilibrium, to make sure all these forces are balanced. Just like balancing on a seesaw, if the forces don't balance, the beam will either slide, fall, or spin. First, we figure out how much push or pull comes from the supports, just like a table's legs push up to hold it steady. Then, we imagine cutting the beam and draw the forces inside it. We write down that the forces left and right must add up to 0, up and down must add up to 0, and the spinning must add up to 0 too. If we solve these, we get the exact number for normal force, shear force, and bending moment. Sometimes we want to know how these forces change along the beam from one end to another. To do that, we use something called shear and moment diagrams. They are simple pictures that show if the inside force is big or small at different points. The shear diagram shows how much sideways force is inside the beam, and the moment diagram shows how much bending is happening. These diagrams help engineers decide where to put extra steel or where to make the beam thicker. There are some cool tricks. For example, if you have a big sudden force on the beam, the shear diagram jumps up or down. And where the shear diagram crosses 0, that's where the bending moment is the biggest. Engineers always look at these points carefully because that's where things are most likely to bend or break. In summary, internal forces are like invisible heroes inside beams and machines that make sure everything stays together. By cutting things into sections, drawing forces, and using simple balance rules, we can keep buildings and bridges safe and strong, just like you would check your Lego tower before adding another block on top.